To start off today, we're just going to review slightly, and we're going to talk about some of these operations. So this says, perform the following operations and write the polynomial in simplified form. So if I look at this first box here, it says it has a binomial, x minus 3 all squared. So if you remember, that's kind of asking us to write this out twice, this binomial out twice. And remember, then we need to multiply. So even though there's no multiplication sign, when there's two binomials next to each other in parentheses, it's basically telling us to distribute everything in one parentheses to everything in the other parentheses. So x times x is x squared, x times negative 3 is negative 3x. And then we're going to take this negative 3 times x, which is negative 3x, and negative 3 times negative 3 is positive 9. And then I can see that I can combine like terms. So I end up with x squared minus 6x plus 9. Again, just a little refresher on some vocabulary. That is a quadratic because that highest exponent is 2. And it is a trinomial because there are 3 terms. In this second box, it's asking you to do the same thing, multiply. So I'm going to let you guys go ahead and do that one by yourself. On this third one, it's asking us to add the trinomial. So technically, since I'm adding, I don't really need to worry about these parentheses. So I'm going to go ahead and just combine like terms. And 1x squared plus 3x squared is 4x squared. If I look at the next term I see is negative 3x. Negative 3x can be combined with positive 12x, and that's positive 9x. And the last terms I see are, remember those are constants, is I see negative 5 and negative 1, and that can be written as negative 6. And that is, again, in standard form, a quadratic because the highest exponent is 2, and it's a trinomial because there's 3 terms. If we had something that said simplify the expression, most of you would say, oh yeah, that's easy, you're going to distribute that 3x to both terms, which you do. But it's important to note that when you're distributing, you're also multiplying, okay? So what we did is we multiplied this through. What we're going to be doing over the next couple weeks is we're going to be going backwards. So we're going to give you this, and you need to go back to there. So if you think about it, it's kind of going in the opposite direction as multiplication. And so what is that opposite operation of multiplication? If you wanted to undo it, then you would do division. Okay, so what we're going to be doing is calling factoring. Factoring is another word for talking about division. Factors, we talked about the number 12, factors of 12 are 4 and 3. So if you wanted to factor 12, you could say, hey, 4 times 3 is 12. And these are the factors, 4 and 3. So if I gave you this expression and I said factor completely, your brain needs to go, okay, I want to try and take something out or undo it. So you need to look and see what they have in common. And I know when I see 3 and 15 that they can both be divided by 3. And they both have at least one x. So I'm going to divide out. I'm going to undistribute. I'm going to put it out here, undistribute it. And think about it. If I wanted to multiply it in and my goal was to get to 3x squared, then I would just need one more x there. And if my goal was to get to 15, then I'd have to have that 5. And this x is already taken care of, so I'm good. So this is the factored version of this. One of the factors is 3x, and the other factor is x plus 5. So when we start doing these factoring trinomials and binomials, we always need to look for a greatest common factor before we do anything. This is your number one step that you always have to do first before you even start a problem to factor. You need to look at it and go, hey, is there some term, number, variable, or combination that I can divide evenly out of all of the terms? And when I look at this, it says and I look at our steps, it says find the largest number that can be divided evenly by all terms, and then find the variable with the largest exponent that can be divided evenly by all terms. Okay, so if I just wanted to find out what the greatest common factor is of 12 and 36, remember, greatest common factor is GCF is just kind of an abbreviation. So if you ever hear me say find the GCF, we're talking about the greatest common factor. So if I look at 12 and 36, I typically go to my smaller number and I go, okay, can I divide both of these numbers by my smaller number? Can I divide 12 by 12? Well, of course you can. Can I divide 36 by 12? I sure can. So my greatest common factor is 12 because I can do 12 divided by 12 and I can do 36 divided by 12. Yes, you can divide both of them by 2 and 4 and 6 and 3 and 9, but the largest one of those is 12. So you're going to do the same thing when you come across variables. I'm going to go to my one with the smallest exponent, which is x, and go, can I divide both of them by x? And of course you can. I can divide x by x and I just get 1. And I can divide x cubed by x and I get x squared. Remember, it has to be divided by them both evenly. So my greatest common factor for number 2 is x. For number 3, I have 12x cubed and 44x squared. Let's start with 12 and 44. So remember, I like to start with the number 12. Start with your smaller number. Can I divide 12 by 12 and 44 evenly? And I can't divide 44 evenly by 12. So let's kind of work down. So 12, 11, 10, 9, 8, 7, 6. 6 can be divided by 12, but 6 can't be divided by 44 evenly. And then we go 5, 4, 4. Can they both be divided evenly by 4? Well, they sure can. So that is that portion of it. I'm then going to go look at which one has the smaller exponent, and it's x squared, and go, hey, can I divide both of these by x squared? And you sure can. So your greatest common factor is 4x squared. And for number 4, I'm going to go to my smaller coefficient, which is 1, and that's, I guess my GCF of that is 1 if you wanted to say 1, but you don't need to, okay? And then y to the 4th is the smaller exponent, and so can I divide them both evenly by y to the 4th? And you sure can. So we're going to go find this greatest common factor, and we're going to write it in factored form, and then we're going to check by multiplying. So I'm going to start with 18x minus 21. So I'm going to start with 18 and 21. 18 cannot be evenly divided by 21. If I go down 17, 16, 15, I'm going to go all the way down to 9. 9 cannot be divided evenly. 8, 7, 6. 6 cannot be divided evenly. So we're going to go all the way down to 3. So I'm going to divide out a 3. Now, 21 doesn't have a variable x, so I cannot take an x if it's not there. I can't take it out. So I'm going to divide out a 3. Remember, I'm going to undistribute. So my goal is, hey, 3 times what gives me 18x? And that would be 6x. 3 times what gives me negative 21? And that'd be minus 7. And then what I want you to do is go check your answer. So you're going to rewrite it and go, okay, is 3 times 6x, that's 18x. 3 times negative 7 is negative 21. Does the original match? It sure does. So that is factored form. One factor is 3. The other factor is 6x minus 7. So we're going to do the same thing for number 6. 7 and 1 are my coefficients. I can take out a 1. That's fine. But my largest GCF, or my greatest common factor, is just x. So I'm going to take out an x. Remember, x times what gives me 7x squared? Well, I need one more x, and I definitely need that 7. Here's where a lot of people make mistakes. They go, okay, well, x and x, that's it, we're done. Okay, but if you leave it here and you remultiply, you don't get that. I need that minus sign. X divided by x is 1. So if you had a binomial and you're going to take a greatest common factor out, you're still going to be left with a binomial. This minus sign doesn't just fall off the face of the earth. And then I just need to go ahead and re-multiply to check my answer. X times 7x is 7x squared. X times negative 1 is negative x. I did it. Great. Okay. I'm going to let you try number 7 on your own since it's very, very similar. And we're going to go to number 9. So when I look at number 9, I'm going to start with 3 and 18, and I see that 3 is a GCF. X to the 5th and x squared. So I need the smaller of the two, that's x squared. So let's think about this. If I re-multiply this back in, I want to get 3x to the 5th. So this is going to be the 3 divided by 3 is 1. If I had 5 here and I took 2 out, I'm going to have 3 left. Minus 18 divided by 3 is 6. X squared divided by x squared is 1. So let's go ahead and re-multiply that back out and make sure that it is accurate. 3x squared times x cubed is 3x to the 5th, and 3x squared times negative 6 is negative 18x squared. So yay, we win. This is factored form. 3x squared times x cubed minus 6.